the tools to be used. This way, when Draw Graphics is run, the tools will be depicted in their actual size. So we'll press F9 to go into the tool page. Put the cursor on the diameter column of tool number 1. Tool number 1 will be a number 3 center drill. So we'll key in 0.187 for the tool's diameter. Cursor down to tool 2 and key in 0.375 for the 3/8 diameter drill. Now I'll put a fictitious Z length offset in the length column for each tool. A -1 inch for tool 2 and a -1 inch for tool 1. Pressing exit will return us to the manual screen. The next step in creating a program will be to press F2, the program soft key. This brings us to the program directory screen, and we can now press F2 again to create a program. The prompt is now asking for the program name. We will key in drill-1 as a program name, for example 1. After the program is created, the cursor automatically goes to that program, and we can now press F8 to enter the edit screen. We're now into the full screen editor with a blank program. The first step in programming will be to give a program number. Program numbers are defined with the letter O followed by up to a 4-digit number. We'll call this O1000. I'll leave 2 spaces, put in a comment character, and also type in the name of the program, drill-1. This way in the future, that name can be referred to. Okay, the next step in creating the program will be to set some modal values like rapid, absolute, or planes, and so on. If we're not sure what the codes are, we can use F1 and go to the help screen. The help screen shows the English equivalent of all the G codes that can be programmed in the control. And I can select each G code, inputting it into the program. So the cursor comes up on rapid, which is GO. I'll press F5 select to select rapid. Now I can press the cursor up to G70 for inch, select that. Cursor up to G90 and select that. Next, I'll want to cancel any active tool. So pressing T0 enter will input that onto the line. Z0 enter will ensure that the Z-axis is raised up. And M5 enter will ensure that any spindle is off. Pressing exit will input that block into the program. The next step will be to move to a tool change position. In this case, I'd like to make that X-3 and Y2. Spaces are not necessary in the CNC control, but I've included them in these example programs for clarity. The next step will be to call up the tool, which will activate its offset. So we'll press T1, leave 2 spaces, the comment character, and put in a comment so the operator will know which tool to put into the spindle. The comment in this case will be center drill, and I'll abbreviate that CTR-DRL. Enter. Okay, the next step is to turn the spindle on and give it an RPM value. Spindle on command is M3, and we'll give it a speed of S2300. Okay, the next step will be to define a drilling cycle to drill the 10 holes with the center drill. So I'm going to use the help menu, and I see that box number 9 contains the drilling and tapping cycles. I'll cursor around to box number 9 and press enter. All the drilling and tapping cycles will be shown on the screen. G81 will be the optimum cycle for center drilling, so I'll cursor up to it and press enter. The can cycle entry graphics come to the screen, and we can now fill in the code. The prompt is asking for finished depth, which I'll make -0.22. Press enter. Start height 0.1 above the workpiece. Enter. And the feed rate can be 12 inches per minute. When we press exit, the CAN cycle will be input into the program and we can continue. The next step would be to tell the control where to drill the holes. Since these holes must be driven to twice, once with the center drill and once with the 3/8 drill, it would be wise to put them into a subprogram. Keeping that in mind, I will now call the subprogram with the hole locations in the subprogram we will later put in at the end of the program. M98 followed by P and a 4-digit number, we'll call it that subroutine number. We'll call it P1. Also, at the end of the subroutine, I'll cancel the drill cycle, turn the spindle off, cancel the tool, and raise Z up to 0, also moving back to a tool change position. So with that in mind, we can go ahead and program the second tool off call, which is T2, followed by a comment noting .375 drill. The next step will be to turn the spindle on at a given RPM, M3 space, and we'll turn the spindle on at S1600 RPM. Next, I'll enter a G83 PEC cycle. Press F1 for help. Box number 9, enter for drilling, and box 4, enter for PEC drilling. We can now fill in the variables for the PEC cycle. Finish depth will be minus 0.52 inches, starting height 0.1, feed rate 10 inches a minute, with a maximum PEC of 0.150. Pressing exit will input the code into the program, and we can now call the same subroutine, M98 P1, to drill the holes. The next step is to end the main program. The code for ending the program is M2. We'll leave a couple of blank spaces for clarity and now program our subprogram. Subprograms also start with the letter O, and in this case the number is 1. So pressing O1, leave 2 spaces, key in our comment character, and put in a comment noting that these are the hole locations. So the comment will read just that, hole locations. Press enter. It's always good programming practice at the beginning of a subroutine to define some modals, absolute or incremental, rapid or feed. In our case, I'll define G90 for absolute and G0 for rapid, because we want to rapid from hole to hole. And now the first location of the first hole. Looking at the blueprint, the first hole location is X1 and Y-1. The next 4 holes are equally spaced in a row, a ½ inch apart. So I'll use the loop command to execute these 4 moves. We'll key in loop 4, press enter, set incremental mode with G91, and the distance between holes is X.5. We'll key in end, and anything between the loop and end command will be executed 4 times in this case. That will take care of the first row of holes. Now the spacing between rows is also 0.5 inches. This will be a Y negative move of 0.5 since we're in incremental mode. At this point, the last hole in that row will be drilled, and we can set a loop of 4 to drill the remaining 4 holes. X minus 0.5 is the increment between holes, and we'll key in N to end that loop. And the next step, after all 10 holes are drilled, will be to key in G80, the cancels drill code. G80 cancels any active drilling cycle, including G83 and G81. So press G80. And now we'd like to cancel the tool and raise Z up to absolute 0 and shut the spindle off. So we'll set absolute with G90, set rapid with G0, cancel the tool with T0, and raise Z up to Z0. At the same time, we will turn the spindle off with an M5. With all that on one line, we'll press enter. Now move to the tool change location, which is X -3 and Y2, and end the subprogram with an M99. Now we have the program keyed in. It would be wise to put in block numbers for troubleshooting purposes. First of all, I'll press F7 move the cursor down to the start of program command, press enter, and the cursor will go to the start of the program. The 1400 has an auto numbering function. It's under F9 miscellaneous. The cursor is on auto number. When I press enter, the prompt will ask me for the block number increment. I'll key in 1, and as we move the cursor down through the program, the blocks will be automatically numbered. When I get to the last block of the program, I must also turn off the auto number function by toggling it once. Again, we'll move to the top of the program, and we can now review it and look for any obvious typos. Everything appears to be keyed in correctly, so when we press exit, CNC will save the program and create a backup file. The next step will be to go into Draw Graphics and take a look at the program. So we'll press F7 Draw. The Draw Graphics screen will come into view. Pressing F5 Display, and the cursor now resting on the Fit command, when we press Enter, the CNC will calculate a window and automatically fit the part onto the screen. The slight time delay you'll see at this point is because the CNC is calculating that window. It's now drawing an XY view of the 10 holes with both tools with the diameters we set in the tool page. The pattern appears to be correct, but I'd also like to look at an isometric view of the same part. Pressing F4 View, moving the cursor down to ISO, we can press enter and we'll now have an isometric view of the same part. We can see the tool diameter and length as programmed in the tool page. You can see that tool 2 is now pecking out the holes. It's now in hole 6, then hole 7, moving on toward the last hole. If any errors were detected at this point, we could always go directly into the edit mode by pressing F2. Since the program looks okay, we'll press F10 and exit out of the edit mode. The next step will be immediately to press F6 to load the program into working memory. Down in the lower right corner of the CRT is a line called Work Program. It's very important that the program you want to run in the auto or single step mode is loaded into the work program. To run graphics or to edit any programs, it's not necessary to load them, but to run them in auto mode or single step it is. So after pressing F6, we'll press F10 and exit back to the manual screen. We can also see at the top center of the screen that drill-1 is the loaded program. So the next step will be to set up our 0 on the workpiece and do our tool length offsets. After that, we can program M105 or M106, which is a dry run code. We can set the CNC to execute the program at very high feed rates to do a visual check. And then finally, after that last checkout, we'll go ahead and machine the parts. Okay, the next step in example number 1 is to find the edge of the vise and the edge of the workpiece. I'll put my edge finder into the tool holder. Tighten it down. Now I'll jog Z down. Set Y to the feed and get it close to position. Next, I can key in a speed command, so when I turn the spindle on, it will come on at that RPM. S1600, and press the start key. Now when I press spindle forward, it will come on to 1600 RPM, which can be overridden with the spindle override key. Select Y, speed, and I'll turn the speed override switch down. I'll creep in toward the Y side of the vise. Move Z down a little bit. Creep Y in. Oops, a little too far. Now I'll set it to 10 thou. Each press of the button will move the Y-axis 10 thousandths. Get close, set it down to 1 thou. And creep in until the edge finder kicks out. I'll turn the spindle off now, and I'll issue a G92 command to set the Y0. Knowing my edge finder is 200 thou in diameter, I'll key in G92 Y minus 0.1, which is the actual location of Y at this point. Press the start key, and Y program 0 is now set to negative 0.1. Now I'll raise Z up. Move to rapid. Set the workpiece in the vise. And tighten it. Now select X to find the left edge of the vise. Turn the spindle on and creep up to the left edge of the vise. I'll set 10 thou increments until I get close, then select 1 thou increments. The lowest setting is 1/10 of a thousandth, which in this case I don't need. Keep bumping the plus key until the edge finder kicks out, and I'll issue a G92 X minus 0.1 on the manual command line and press start. That will set the X0. Now just to check it, normally you will raise Z to a safe height and tell the control to go to X0, Y0. You can set G0 for rapid, X0, Y0. When I hit the start key, the axes should move to 0, 0. Now a visual check can be done to make sure a mistake was not made setting it to the wrong side of the workpiece. Since that looks okay, I can raise Z up manually, or I can command Z to go to 0 by pressing Z0, start. Manual commands can be given on the command line. The next step is to set the tool offsets. It's always good practice to keep the table up as close to the spindle as possible while machining. So to accomplish this, we determine which tool of the two for this example part is the longest tool. In this case, it's tool number 2. So we'll take the longest tool, tool 2, put it into the spindle, jog it over the workpiece. We'll select the X-axis, select feed, press the plus key, select Y, minus. Now, we'll raise the knee to a safe height, keeping the table as close to the spindle as possible. I'll leave about an inch between the tip of the tool and the top of the workpiece. Okay, once the table height is set, we can do the tool offsets. Select X, and I'll move the tool away from the workpiece in feed. Remove tool 2 and place the first tool into the spindle. In order to do the tool offsets, you first must jog the machine over the surface to be offset from. In this case will be the top of the part. So I'll select the x-axis, rapid, and jog in the plus direction. Slow it down to feed. Now I'll select Z and carefully jog the tip of the tool down. Now I'll select the 10,000ths per increment and carefully jog the tool tip down to the workpiece. When I get close, I'll select even a finer increment, which is 1,000ths per push of the button. Each time I push the button, the Z will go in the negative direction 1,000th of an inch. Now that we're in contact with the offset surface, the next step is to go directly to the tool page, press F9, place the cursor on tool number 1, and press the Calibrate Z key. The Calibrate Z will automatically input the offset dimension into the tool table, into the length column for tool 1. Pressing exit will remove us from the tool page. Now we can jog tool 1 up away from the part. I can give it a manual command to go to 0 in rapid, which would be G0, T0, Z0. This will ensure that the axes will wrap it up to its home position. Okay, now I'll select X and jog tool 1 away from the workpiece. Remove it from the spindle and place tool 2 into the spindle. We're now ready to do the length offset for tool 2. Again, we will jog the machine over the offset surface and carefully jog Z down to the top of the workpiece. Selecting 10,000ths per increment. We'll continually press the minus key until I'm close. Then I'll select 1,000th to do the final touch off. Once I'm touching off, again, I'll go to F9 tool page, move the cursor down to tool 2, press Calibrate Z, and press exit. I'll press Z0 start, and the Z axis will wrap it up to the home position. Now I'll command it to go off to the tool change position, which is X minus 3 and Y2. Press the start key. Okay, the next step in the first run of a workpiece would be to dry run. That is to say, we can run the machine without actually cutting the workpiece. There are 2 dry run modes, and we can find these through the help menu in the manual mode. If I press help, F1, toggle around to the miscellaneous M codes, and press enter, I can see that M105, M106, and M107 are dry run codes. M105 is dry run with all axes, M106 is dry run without the Z axis, and M107 is dry run off, which will turn off either of those codes. In this case, I'll choose M105, dry run with all axes. And I'll remove the workpiece from the vise, let the machine dry run the program to inspect it, and then we'll turn off the dry run, place the part back into the vise, and cut it. So I can move my cursor down to dry run all axes, press select, and press exit, and that M code is input onto the command line. When I press start, that dry run is activated, and I can see that by looking at the active M codes on the screen here. Okay, so I'll place tool number 1 into the spindle. Now the dry run modes execute all moves at a very high feed rate. So we would not want to have them part in the vise at this point. I'll remove the part from the vise. Ensure that drill 1 is actually the loaded program, and we'll press auto. The CNC will come up to block 1 in the program. When we press the start key, it will stop at block number 3, which is the tool 1 call. With this machine configuration, the tool light will come on, and when the tool light is pressed, the program will continue. So I'm going to override the rapid rates down low so we can visually inspect this first run here. Okay, it seems to be going fine, so I'll increase the override back up to 100%. Okay, tool 1 performed perfectly. We'll remove it from the spindle and place tool 2 in the spindle for its dry run. The tool light is awaiting to be pushed to execute the program. Again, I'll override the rates down, press the tool light, and carefully watch tool 1, pardon me, tool 2, to see that it's performing correctly. Okay, it seems to be working fine. So it's in the dry run mode on the 4th hole of row number 1. Okay, it's starting on the 2nd row, working back toward the X0. Okay, the program ended normally. The next step is to turn off the dry run mode. So I'll go into the manual mode and press M107 and hit the start key. I'll see that the dry run has been removed from the CNC. So we'll now place tool number 1 into the spindle to get ready to cut the first part. You can never be too safe when machining the first part of a production run. So we'll place the part back into the vise in its original location. Make sure it's set. Remove the vise handle and put on our safety glasses. Okay, press the auto key. Again, since it's the first actual run of a part, I'll override to be extra careful. The tool light awaits push. We'll push it and allow tool number 1 to do its operation. I'm overriding the spindle RPM and feed rates for tool 1. It was actually programmed to be a number 3 center drill. Since that tool was not available, I went to a number 1 center drill. I'll take note of the RPM and feed rate that it's currently running at, and we will edit the program accordingly after the first part. It's always best to run your tools at 100% feed rate and 100% RPM override. Okay, tool 1 was fine. Remove it and place tool 2 into the spindle. Again, on this first run, I'll override the rapid rates to be extra careful. Pressing the tool light will cause the program to begin execution with tool 2. Override the rapid rate and feed rate with the feed override switch, and override the RPM with the spindle override switch. Again, I will take notes so I can edit the program to get optimum cutting. I'm noting the RPM and feed rate. The feed rate is fine at 10 inches per minute. The RPM, however, I will edit. Note that there's no coolant being run on this part for demonstration purposes. Okay, it's drilling hole number 7 of 10 now, moving on to hole number 8. And finally, the last hole. Okay, at this point, we should get the first part inspection done. And now I will go in and edit the RPM and feed rates for the tool. Press manual, press F3 edit. It brings us directly into the program. I'll move up to the speed code for tool 1 and change it to 3,800 RPM. I'll change the feed rate to 4 inches a minute. Okay, moving down to tool 2, I will edit its RPM to 1570, and we can leave the feed rate at 10 inches per minute. The second example part is also an aluminum plate, 1/2 inch thick, 11 inches long, and 8 inches wide. It contains a rectangular pocket, circular pocket, and a slot milled into the interior of the part, and then a contour cut around the perimeter of the part. First step again will be to go to the tool page, F9, and enter the diameter and a fictitious Z length offset. Cursor over to the diameter on tool 1, key in 0.75 for its diameter, press the cursor right key, and key in a -1 as a temporary offset. Pressing exit will move me back to the manual screen. The next step will be to go to soft key F2 program, and we'll create a program called mill-1. To create, press F2. The prompt is now asking for the program name, so we'll key in mill-1. Press enter, the program will be created and the cursor will automatically go to that program. Now when we press F8, we'll be into the editor with the full screen and the blank program. The first step of editing is to give a program number. Program numbers are denoted with the letter O followed by up to a 4-digit number. We'll call this O2000. And the comment will be mill-1. The next step is to set our modals. Again, we can use the help menu if we're not sure of the G codes. F1 will bring us to help, and I can select each G code, building a block on the input line. I'll also want to cancel any active tool, raise Z to 0, and turn the spindle off. The next step will be to move to a tool change position, X-2, Y2. Okay, the next step is to activate tool 1. Press T1. I'll put a comment for the operator. 0.75 mil. Okay, the next step will be to turn the spindle on and give it a speed. Spindle on command is M3, and the speed we will set to 950, S950. Okay. The next step, the first operation will be to mill the rectangular pocket. According to the manual, I must drive the tool over the lower left corner of the pocket, which in this case is x1, y minus 4. Now I'll use the help menu to input the pocket. Press F1 for help. Pocketing is box number 7. 7, enter. Rectangular pocket is the 5th box. I press 5, enter, and the rectangular pocket will come to the screen. The length of the pocket is 5 inches. Press 5, enter. The width is 3. Starting height of z-axis is 0.1. Z-depth is minus 0.281. Corner radius of the pocket is 1 inch. The tool step over is 0.43 inches. Maximum Z-cut is also optional. Any input without a 0 is optional. I'll leave the Z maximum cut to the default, which will be full depth. Ramping feed, 7 inches a minute. Roughing feed, 13. Finish stock, 0.015. Finish feed rate, 10 inches a minute. Retract height will default to the start height. I'll press exit, and the code is input into the program. The next step is to mill the circular pocket. I can go directly to help again. And if I know the G code, I don't need to go through each individual window. I can key it in here, G77, press enter, and the circular pocket will automatically come to the screen. First two entries are the pocket center. They're optional. If you don't program them, you must be over the center of the pocket. Since at this point we're not over the center of the pocket, I will key in the first two entries. Center of the pocket in X is 3 inches. Center of the pocket in Y is minus 6 inches. Start height is 0.1. Absolute depth minus 0.25. Diameter of the pocket is 1.75. The tool step over is 0.6. Maximum Z-cut will leave to default. Roughing feed, 11 inches a minute. Since in this case I don't want to make a finished pass, it's not necessary to key in finish feed or finish stock. Pressing exit will input that cycle into the program. The next step is to peck a starting hole for the slot. So I'll use a G83 to peck out the left-hand end of the slot. Again, using the help menu to input the drill cycle. Drilling is box 9, enter. G83 is box 4, enter. G83 cycle comes to the screen. I'll key in the depth. The slot depth is 0.125. So the starting hole I'll make negative 0.12. Start height 0.1. Feed rates 6 inches a minute. Maximum peck 0.06. Pressing exit will move us back to the program. The next step is to tell the CNC where to drill. We've told it how to drill, but not where yet. The starting location of the slot is X7, Y minus 6.5. That will peck the starting hole for the slot. The next step is to cancel the drill cycle with G80. Now we'll feed to depth. Feed code for feeding is G1. The Z depth is Z minus 0.125 at a feed rate F5. Now the next step is to mill the slot. Since the tool is 3/4 inch diameter and the slot is 1 inch wide, I'll use cutter comp to move up and around the slot. So the first move will be a Y positive move, and I'll use incremental mode. Incremental is G91. Cutter comp left is G41. and the y dimension incrementally is 0.5, y 0.5. I'll also want to pick up the feed rate to 12, keying in F12, and press enter. Now I'm at the 12 o'clock position of the first arc of the slot. Showing several ways to do arcs, I'll use the help menu to input the first arc. Press F1 for help. Move the cursor up to arcs, press enter. All the possible ways to define an arc come up on the screen. The first arc, I will show you the center and endpoint definition. That's the industry standard. If a mistake is made, the help menu knows that the last move made through the help menu was a linear move, so it tells me I must program G2 or G3 first. So I'll use the cursor to back up the G3 command in this case, which is arc counterclockwise. The help menu shows you the English equivalent of any G code, therefore training you at the same time you're being productive. Select a G3, move back up to the center and endpoint definition and press enter. Now the arc format comes to the screen and I can key in the numbers. Knowing that I'm in incremental mode, I want to do a full half an arc. So the endpoint in X is 0 incremental, endpoint in Y is -1 incremental. The center point in X is 0, the center point in Y, -0.5. The other two optional entries are for helical movement, which we won't need at this time. Once the arc is filled in, I'll press exit and it's input into the program. The next step is to move along the length of the arc, the length of the slot, which is 3 inches long from center to center. I'll press G1 for linear feed, X3 to move the 3 inches to the right. Press enter. The next step is to do the arc on the right end of the slot. Again, I'll show the help menu and press 4 for arcs. Again, I will select counterclockwise, this time using the center and the radius and endpoint definition. The endpoint in X incrementally is 0, the endpoint in Y is 1 inch, and the radius 0.5. This shows another way to do the same arc. Press exit and the arc is input into the program. The next step is to mill along the top of the slot, which is a -3 inch move in X. Setting the control back to linear feed with the G1, I'll key in X -3 inches. The next step will be to move back to the center line of this slot, turning off compensation at the same time. G40, Y -0.5 will accomplish that for us. All right, the next step will be to raise the tool up out of the slot in rapid mode. Also in absolute, so the first entry on this block will be G90 to set absolute, G0 to set rapid, and Z.1 to raise the tool. Okay, the interior of the part is done now. The rectangular pocket, the circular pocket, and the slot has all been milled at this point. The next step will be to cut the perimeter of the part. Assuming that the part is screwed down to a fixture, and I can mill all the way around the outside without any interference. The next step will be to move to a starting position. Since X0, Y0 is in the upper left corner of the part, I'll move off to the left of that, X -0.4 and Y 0.4. That will rapid the tool to the starting position. The next step is to feed Z to the cutting depth. Since I want feed, I will key in G1, Z -0.52 at a feed rate F13. Next step will be to turn cutter compensation on, left of path, and move to the Y0 line. G41, Y0. Now we'll mill the top edge of the part, stopping at the arc center on the right end. The dimension is X6.5. I'll key in an arc using the radius and endpoint shown earlier. G2, X 7 inches, Y minus 0.5, radius R 0.5. That will cut 90 degrees of the arc. Now the next move on the blueprint is shown incrementally, and it's 3 inches negative in the Y-axis. I'll switch to incremental using G91, switch to linear feed because the arc is modal, the previous arc. That's accomplished by G1, and then the Y dimension is Y minus 3 inches. Now I'll use the help menu because I have an angular move here shown on the blueprint. The angle shows negative 30 degrees, but there's no radius given. I do know that the stopping point will be X 11 inches. I do not know, however, what the Y dimension will be. Using the help menu, I can accomplish this. Go to help, F1. I will set absolute, knowing that the last move was incremental. I'll select absolute. I'll also select G1. The last move entered through the help menu was an arc. Therefore, it would give an error if I tried to do a line. I'll move up to box number 3, lines, and I'll use the angle and horizontal selection. Horizontal is the x-axis, vertical is the y-axis, while you're programming in the XY plane. Pressing enter, the format for that will come to the screen. The angle is minus 30 degrees. The horizontal dimension is 11 inches. Press exit, that line will be input into the program. Now the next step is to make the Y move to the center point of the next arc, which is on the lower right corner of the part. That dimension will be Y minus 7 inches. Now the next step is to do the arc using the end and center format. Again, I can use help if not sure how to program the arc. Move up to the arc box, press enter. Select G2. Then use the center end definition. The absolute endpoint is X10 and Y minus 8. Since I and J are always incremental in arcs, the I dimension is a -1, the J dimension 0. That will cut the arc on the lower right corner of the part. The next step is to mill along in the x-axis a linear feed, which is G1, to the center point of the last arc, which is on the lower left corner of the part. The dimension is X2. Now, showing one more possibility of arcs, we'll press F1 for help, 4 enter for arcs, select the G2. This time we'll show the center and angle arc definition, which is box 6. The center point in X is 0, the center point in Y is positive 2 inches, and the absolute angle is 180 degrees. The polar coordinate system defines 0 degrees at the 3 o'clock position, 180 degrees at the 9 o'clock position. Therefore, the end point of this arc is at 180. The next step is to initiate linear feed with the G1 and feed the Y-axis right off the part to Y positive 0.5 inches. Next, we can rapid Z up out of the cut, G90, G0, Z.1. G90 was not really necessary since we're already set to G90. If you care to delete it, cursor over, press the delete key 3 times, press enter. The next step is to ramp off the cutter compensation with a G40 and a move. To accomplish that, we'll press G40 X minus 0.5. The next step is to cancel the tool, raise Z, and turn the spindle off. Accomplish that with T0, Z0, M5. Okay, the next line on our program sheet is to move to a tool change position, X minus 2, Y2, enter, and end the program with an M2, enter. Okay, now we'll move back to the start of the program and use the auto number function to put block numbers. Again, block numbers are not necessary, but they're very helpful when troubleshooting the program. We move to the start of the program, press F9 miscellaneous, press auto number. The block increment is set to 1. As we move the cursor down through the program, block numbers are automatically put in. Must turn off the auto number function by toggling it once more. Move to the start of the program. I can review the program for any obvious typos. Since the program looks okay, we'll go ahead and exit. The CNC will save the program at that point. Now we'll go directly to Draw Graphics, hit F5 Display, press Enter, and it will automatically fit the program on the screen. The delay is the CNC is calculating the size of the part so it can display the full part onto the screen. In this fashion, no scaling factor has to be set. It's automatically fit onto the screen. Now the part starts to draw on the screen with the tool diameter we previously entered into the tool page. At any time, I can toggle the text, the program text, off. I can program the static tool off, and I can program the rapid rates on or off. I'm sorry, the rapid moves. Rapid moves are depicted in red, feed moves in white. The graphics parameters are set to use both cutter comp and show the path without cutter comp. So the draw graphics will first run the part without compensation, then rerun the part with compensation. Compensated moves are depicted by green lines. We can see that the compensated moves only apply to the slot and the perimeter of the part. Now I'd like to take a look at the XY view. Since we saw an ISO view, it's always good to look at more than one view of the part for troubleshooting purposes. Circular pockets being done now. Now the slot. Now the perimeter of the part. Now the program starts over using cutter comp. Again, the static tool can be turned off at any time. The text can be turned off. We can go to single step by pressing block or motion. If we go to motion, one motion will be executed each press of the start key. This way, each individual move can be inspected. We got no errors on the part. Everything looks fine. It looks like the blueprint. So we'll exit out of Draw Graphics, load the program using F6. That loads it into the working memory. Pressing F10 will exit us out to the manual mode. Now we can set part 0 and do the Z-length offsets for tool 1.